And so our plan is to make an exciting dinosaur movie, having this dinosaur riding on this cart. And we're going to film it by mounting our camera on a cart beside it, like that. And so here's the whole setup. Chompy the dinosaur is going to be riding on this angled track, and you can see that the angle there is 30 degrees, clearly marked. We are going to ride our cart, we're going to ride our camera on this cart, and it's going to move along what we would call the x-axis, and it's going to keep up with Chompy. So the question is, given that that's a 30-degree angle, and that Chompy is going to travel with a particular velocity down that track, what velocity do we need to pull our cart with in order to keep up with Chompy along the x-axis? And so we'll just give you a little example of how that's going to work. So we can collect now. So we'll start to collect data. We'll collect our velocity data. Go ahead, yeah, and give Chompy a push. Chompy is moving at a nice constant velocity, and our cart is moving at a constant velocity. So our cart is keeping up with Chompy in the x direction. And how fast did Chompy go? Chompy moved at a fairly nice uniform, it looks like. Chompy moves at a nice uniform 25 centimeters per second, and there's a little bit of variability, but that's almost exactly 25 centimeters a second. The question is, if that's 25 centimeters a second, and that's a 30-degree angle, how fast are we going to have to pull our camera cart?